So Mohammed, lovely to have you on the call. Tell us a little bit about your background and tell us a little bit about the story that led you to efabless. And also after that, we'll talk a little bit about your relationship with the OSFPGA Foundation. So yeah, a little bit of background, please, Mohammed.
So first of all, thank you for letting me do this and introducing me to the community. And also, I'm looking forward to further interaction. Yeah, so my background is in electrical engineering, just got shaped over the years with the career path, different career path. So I was, when I just graduated out of college, I was a part of the founding members of Mentor Graphics in Egypt. It was a company called AnaCAD, and then it got acquired by Mentor Graphics. And I stayed with them 5 years, primarily doing a lot of team building and knowledge transfer. After that, I moved to North America and I went to University of Waterloo for my graduate school. And then from which I went to TI, working in a wireless group in the year 2000 when TI was starting about to make chips for applications processors with Nokia, when Nokia was the king of all.
Yeah, we remember Nokia, don't we? We all remember Nokia.
And it was a significant chunk of TI's business back then. During that, TI was driving the first analog integration on CMOS. So I was at a part of that group where we're trying for the first time the analog integration on the digital CMOS process, vanilla digital CMOS process without any additional components. And that was actually very interesting because we got to work with the process development people and learn from them a lot about how they're constructed. Sometimes we actually help spec what's required for the analog. And that was an incredible experience and enlightened me a lot.
Yeah. It reminds me a little bit about the Apple and Imagination relationship. Imagination Technologies, I think they were big in the UK. And I think they had this relationship with Apple. And I think when Apple took some of that design in-house, I think they were very badly affected by that. Did that sort of thing happen with Nokia as well? It seems there's some parallel.
Actually, TI is actually had a very strong management team that actually knows this, senses exactly what you're saying. And I remember I had a conversation with one of my mentors, TI. He is basically saying, I would like to lower the revenue and make it more robust. So more customers versus a few big customers that actually they said, I don't want to be waiting for the phone call.
Yeah, your whole destiny is tied to one company. That's very, very dangerous in any business.
And TI did a good job getting out of what's not positioning them as leaders. Anything that they don't feel that they're taking the leadership, they start. That means it's stealing. It goes in the wrong direction. So deliberately.
Awesome. So TI. So just talk a little bit about TI because it's a big company, right? They do all sorts of chips, right, across many, from I guess discrete components all the way through to the MCUs and the CPUs, I guess, as well. And even digital signal processors and so on. So did you see some sort of like with every company, there's an evolutionary path. Did you see that company, because some companies, they stagnate, they just kind of like, they just level off and they don't really see much upside. They don't put enough money in or the right people into the R&D. How was your journey with TI? Did you feel that you were pushing forward?
So actually in the wireless group, our team was called Just Do It.
Okay, cool.
JDI. And because there was a lot of skepticism whether you'd be able to integrate the analog on digital and actually comes out as useful analog, especially in the wireless domain. So the team was supported with a huge amount of funding to be able to go try things. So instead of actually arguing about it in simulation, just put some test chip and put some analog, put some digital, and actually I was responsible for actually taking data out of these chips and quantifying the noise levels and all that. Yeah. When the process was new, so it was millions of dollars. TI was very committed to that. And then over time, they created the so-called Kilby Labs or Kilby Center. That Kilby Center is more of an incubation ground coming from the internal employees. They can actually move to the Kilby Labs, get a budget, and then they have the opportunity to start something that could potentially graduate to a product line. So
they kind of use that sort of that creative energy to sort of springboard off of to get commercial products out the door.
Correct. Yeah. I do attribute a lot to the specific leadership because they cared about the customer and what the customer needs and how you meet them. within the confines of a standard product marketing or business. Sorry.
So you enjoyed your time there, and you obviously learned a lot. So did you see any gaps in the market where you were there? Like, were there things that in your domain that you thought, oh, hold on a minute, there's an opportunity? Because you know what they've done here in Australia, there's a company called Morse Micro. And what they've done is, with long range sensors, particularly via IoT devices in the field, they normally use a LoRaWAN or some sort of long range, low power radio. But Wi-Fi is a very popular protocol. What they've done is they've gone in, they've designed a wireless chip with very long range and low power just to tap into that little niche. And they said the reasoning behind this is because the big boys don't even want to touch this. It's just not big enough for them, that niche. So these are little opportunities that can come up. And if you have enough funding, it can sort of translate.
Yeah. And this kind of niche opportunities have an interesting behavior. So TI, a company like TI in general, not just TI, you can call it analog devices, NXP, STM. There is the big hits that are high volume. They have a huge array of products that sell to smaller volumes. In general, to define a product, that ratio hit or miss 50%.
Yeah.
You can have it develop a product and spend the money doing it, and then it doesn't sell to recoup the money that is invested in developing that product. So I found that there's that general problem, which means that if you have a process that allows you quickly interact with the customer and iterate with them in a clean way and have a medium that can be reliable and robust, then it's possible.
I think with this, guys, what they've done is, original Wi-Fi was invented in Australia, and the guys that sold out of that technology are behind this venture as well. They're funding it. And so there's a little bit of momentum there. That may take this thing somewhere. But yeah, there's lots of people disrupting this space in the radio area as well, in the 5G area as well, and satellites as well. Like you said, it's a risky venture, and sometimes the timing is all wrong.
And that's exactly right. You can develop something and then it doesn't sell today, but if you have it as a part of your product portfolio, you can peak at a different time later.
Yeah. So after TI, did you continue with your career, or did you branch off onto?
No, I actually stayed with TI for 11 years. Responsible for.
It's a long time, yeah.
By the end of my term there, I was working on first analog on the technology. So we were driving the process development with initial products. After that, I basically switched for the last year to the business development side, and I was responsible for the business Motorola business. TI for OMAP.
How was that for you? How was that transition? Because I know that doesn't always work out for everyone.
It's a funny story. I have my personality, and at some point I had a disagreement on something in a policy that was established for travel. And so I called, the GM, and I asked for a meeting, and then I talked to him. I just said, why is it this way? And I think it should be that way to improve accountability. He said, done. And by the way, do you want to work with us on the business development side?
So you were a good negotiator, obviously, right? Because
I didn't hear it before, but that was the first time anybody offered that, because it's actually very hard to actually move from a technical background and all of a sudden.
Yes.
So he said that, and in the same second, I said yes.
Well, it was destiny then. It was meant to be.
And then that was a very enlightening experience, because you work with a different group of people. Most of the work related to Motorola was related to you have the chips, but you deliver the whole stack. So you work. I got involved in the knowledge of application development and Linux support for the device, and actually how to companies like Motorola think about the competitiveness for themselves and what they would require from us. Yeah,
so you made the transition quite successfully because you have a certain personality, and it does rely on personality in the sense that, well, there's a certain sort of psychology, but certain bravery as well, and obviously the notion of working with others, negotiating. So you work with them as a BDM for a little while. I mean, did you see things differently in the world? From obviously when you're an engineer, you're very narrow, right? You're in the weed.
Yeah, and I had to. So I'm coming from an analog background, but in order to open the door for new business in something like the applications processor for the smartphone, it's that I had to learn a lot more things around it, learn the benefits and the needs, and what is the difference in the camera type and how we would influence that and enable the company to make a better camera, both codecs and software as well as hardware. I was surrounded by a great group of people that I was like a sponge, just learning from them. And that's the most rewarding part of this.
So did you act also like a field application engineer as well? Was there an element of that as well going on in the BDM activity?
No, there were field application engineers that work with us.
Okay.
So that's a part of the team that is around me. And that's the beauty of having a complex and diverse team. And so we interacted with them, and we also know what their problems, because what they're thinking, because they are in the field with the customer.
And so were these large projects with the long lead time in sales lead time, or were they shorter lead times?
It is a long deal because you commit to it, but it was primarily driven roughly by the cycle for the smartphone, like every year.
Right.
So the Christmas and the Thanksgiving holidays, they set the delivery times and execution times at the end of the project. So call it the start in 2 years, but you stagger. So you start 2 years hitting for 2 years, but you already started a year before what's coming this year.
All right. So I guess that taught you a lot about the whole stack, from the idea all the way through to the final consumer product or whatever industrial product, whatever it may be.
And I did have mentors outside that were actually very they lifted my knowledge up.
So what do you think about mentorship though? Because I'm like, I don't know. There's a lot of noise out there. So what are your thoughts on that?
There was no mentor that was assigned to me. I see people around me. I like their approach. I actually ask them for time. Some of them say, "Do you want to do this again?" And I say yes. And I'm talking here about senior vice president level. These are So it was so I selected people that it would be, I call it natural selection, because there's also the personality resonance aspect. But when you approach somebody who is more senior, generally speaking, they would want to give advice, and also the good ones of them, they don't actually tell you what to do. So they give you options to try from and suggestions. But
great, awesome. Okay, so what happened after your BDM role?
Yeah, so I left TI in April 2011. Yeah, and I spent a couple of years navigating the globe, but I knew what I wanted to do, but I wanted to have a clean break and completely start from scratch. So that day I quit. Second day I started incorporating some entity and started working.
Okay, cool.
And the direction was, it's an idea that sparked between me and one of our partners currently, sitting in a room at one of the conferences. That's a different story how we met and all that. And then I started working on it, and in order to actually do this, you have to do what we do, which is in essence to simplify the process of chip development and make it easier. Then you need to talk about the PDKs or the foundry relationships. You need to talk about the EDA software, the knowledge in general. If you're building a useful chip, you have more. It's usually more than your own domain alone. So you need collaboration, complementary knowledge, as well as the affordability. I was lucky enough to have a project that landed on my lap, basically as a consulting, that enabled me to interact directly with the right levels of the management at the foundries. Awesome. So I was able to, on dinner, I say, I'd like to do this, and some they say, "Oh my God, I want to help. Let's meet tomorrow morning before our other project." Or some they don't resonate. But in general, foundries recognize that the approach we're taking for efabless, if successful, back then, it would increase their wafer revenue.
So how were you able to get an audience with these people? Was it just through the connections that you had or the sort of work that they already know about that you've done?
Maybe one of them, it was through a connection, but the biggest one was that consulting project where I was working with a government of another country to help them build an electronics infrastructure, which I didn't build myself before, but I know what I don't know. So I started engaging other people, and they had a big budget. And when you have a big budget, it puts you in the right places.
100%. You get stuff done, right? But it's also having confidence in yourself, isn't it? It's putting yourself out there and saying, even if you haven't done it before, it's like, yeah, okay, well, I've got the smart stuff. I can put it together.
Yeah, and literally, I wrote one letter with everything I want, and I put it on LinkedIn to several CEOs of foundries, and almost 90% of them all came back, and we ended up visiting them. Some of them were skeptical. Who are you?
Yeah.
But when you see it, and I bring with me the right people from the responsible for the funding, etc. Becomes real.
Of course. I mean, why would there not? I mean, that exactly, you've got to have that support behind you, and it's got to be real, right? And people recognize that anyway, right? These people that you're dealing with, they would know, right? I'm sure they've been hit up by many people, right? They know the difference between what's real and what's not. So
yeah, one of them was not. So I said, okay, if I'm right and I'm real, there's an opportunity. If I am not actually real, then you don't lose anything.
Exactly.
And that was it.
Awesome. So on the back of that project, which you obviously delivered well, you then had other ideas that sprung forward. And this is going back to the idea of simplification. Yeah. So trying to simplify that process of doing chip design. So lead us through that journey in your mind, and how that idea cemented into reality, and where, I guess how it came to be efabless.
Yeah. So for that, let me share a couple of slides. That's what we wanted, to simplify the process and make it available and open it.
Yeah.
In order, the one effect that you can actually play on and actually see what people are doing is that what happened in the software industry when the marketplaces for apps came. Before then, you'd have a software company building a software that has to be compatible with operating systems, and when the concept of app marketplaces came out, 1,000x, maybe 100,000x, I don't know, able to develop apps.
Well, this is the same idea of the Amazon story and the Alibaba story. They originally had their own inventory, and then they open it up to everyone else.
So in this case, the concept was they give the tools, they give a marketplace and a business process that allows the developers to interact, which is the marketplace, through the customer. So there's no reason for many integrated circuits that actually have a similar twist to start from. If you look at these niche products, they're not 100 people designing a chip. Like there are chips I was working on. There were hundreds of people for everything, including the software. There are many of the niche products that they are developed with very clever engineers, and we want to democratize the tools, the business framework, and access to the customers. If you think about what's needed, so that's what's needed. I mentioned earlier. I call it the end gate, because if you don't have that, you can't have a useful system at the end. And it has to be, when I say useful, meaning it's not a total, something that's market relevant. There are some partial solutions for this now, but what we want to go like all the way. So the solution basically was envisioning this in actually like browser. It has to be, that was my definition, browser accessible, cloud-based, one-stop design ecosystem in a box. You get in the browser, you're able to design instantly.
Now, something that Naveed mentioned, just want to bring that up quickly here. He said that in his talk, he said, we stop you from screwing up the chip design. What did he mean by that?
The part of the simplification process is to build, there are two things. In the design methodology itself, you build like guardrails, or like the train. You can design any train you want, but here's the rail.
Right.
Don't get out of that. On the other side, we can actually build a piece of the train and say maybe build the engine, and say you build the rest of the train. Some of the critical pieces We already pre-developed them and stabilized them, and many people would use them.
So whatever you build on top of your framework isn't going to screw up the base framework. The system will tell you, hey, listen, this is not going to work out, right? What you're trying to do.
Yeah, and it needs to be flexible enough. So that's what we did. So what we started, we provided the tools. We put in the tools certain hooks and guidelines and walkthroughs to be able to. And we started with the tools. We wanted to, in order to get to, we give it to anybody, anywhere. Apple had the SDK, we didn't, of course. So thanks to the community collaboration from the open source EDA world, they helped us assemble a complete design environment. Takes you from idea all the way to tape out.
So let me ask you this, because these are complicated tools, and you're saying they're browser-based. How was that? How was that to implement? How easy or challenging was that to put that?
Well, the technology aspect of this, to be honest with you, is not hard. The technology. Okay. So what we did really, we assembled key applications, including that browser accessible. It's an open source application.
Okay.
But that by itself is just gives you access to a remote desktop.
Oh, okay. All right. Okay. Got it.
But what we did is that we took it, we added authentication to it in a certain way, and then we added the tools. With that desktop that's available.
All right. So it's a desktop access through that. Okay. So when you're doing the routing and the processing of the design, the compilation of it, I guess, does that take time, and how does that work on the back end? I mean, does that run on certain specialized machines, or does it run on particular servers? How does that work?
Well, I don't have an illustration here. We have a general, it is in the cloud. You may actually, if I zoom in here a little bit, basically there is an interaction in the user space where they can actually use IP that is available on the platform. And EF3 is an application stack that we developed to consolidating the applications to work with directly. And then when the user starts to work with OpenGalaxy here, we actually invoke a machine for them to work. The cycle time depends on the size of the design and the verification required.
Okay, so it's kind of using some of the Amazon. I can see Lambda there. Are you using Amazon?
The Amazon infrastructure. And the reason we used Amazon is that we evaluated several of them, but at the time in 2012 or 13, Amazon was far ahead in terms of APIs and flexibility. And continue to evolve this way, but others are now getting in shape.
Amazon is good. There's a few others now coming up, but definitely. Okay, awesome. So you spin out a machine based on the requirement, and then you spin it down when it's not needed. Okay, awesome.
If I wanted to show you just what I was talking about here, so if you go to efabless website, so when you go to the website, you'll see a lot of things. The marketplace that has IP. Okay. And you'll see the public projects that are submitted by designers.
Awesome. Okay.
Space. And then you can do this on your own. You register with one of the authentication systems. And then now I can go to start my desktop like this. And if I already had it started, like now, you see it immediately available. So it is available.
Oh, okay. All right. That's quick. That is quick.
But if this is a chip, I'm just going to open the layout. You can see how snappy it is.
Oh, it is. It's very quick.
We also change little things like the rendering. You don't have to render the whole layout so that you don't have things like that. And then you can do analog and digital. So
so that's a good point, because the guy did ask is it mixed signal as well and analog? So you can do both.
So one of the examples here, if I wanted to create a new project, I have a library of process technologies with different options, stacks, some of them with different levels of metals, etc. So a project like if I create a project and open it, you'll see as you open it, number one is that it will have examples of already existing experiments and designs that are working out of the box. So if I wanted to, this is actually just if I zoom in on this, because of the tools, I don't remember. Okay, so I don't remember the zoom shortcut. The changes from software to software. That's trying to fix. Anyway, so that's a simple circuit, but it has all the put a supply and a pulse and process corners, and then you can just simulate it, and it will run out of the box. This is for a new project. So you can borrow from this if you want it.
Okay.
If not, you start a blank circuit from scratch.
So this is really so it's a set of libraries, I guess, or components that you can plug and play, and then you can create something, simulate it, get something sort of an initial design, get it out, see how it fares, then go and tweak it, iterate it quickly, and then pop it out. So the iteration phase, I mean, I guess for from the projects that students have done in the past, some projects, or even the stuff that you guys might be doing commercially, how have the engineers how have they taken to this environment?
We've had several use cases for the platform. So, and I don't know if I might have a slide here talking about it. No. So one of the things that we started with was a challenge. So design challenge where a customer wanted a design, and we just opened the challenge and we said, here's the spec, and come in and design, and you'll get two things. You'll get rewarded. You will own the IP. So the customer was actually okay with that because it was a foundry. And then it was surprising because it was an analog design, and we had, I think, 80 participants. 13 of them went through the final horse race, and 6 of them finished the schematics, and 4 delivered layouts.
So they were able to use it pretty quickly and effectively.
And the designs, the design outcome was actually put on silicon and tested.
Okay, awesome. So just stay on that for a minute. Like, so let's say some students do get involved. Is there like a training program, or is there sort of a coaching or something to get them into the project?
To start with, we actually, one of the things we knew that it exists, there's a need for it, is that if I go to, we created a resident like knowledge base. So you can have general how-tos are actually very important. Basically, how you do things. Like one of them is actually taking you step by step, even click by click.
Awesome.
And then when we started the projects with Skywater, actually, now we have a lot more resources outside, and we're trying to fold them in as well.
All right. And so what about so this is great. This is online. They can go in and they can look at this right now, right? I mean, you just go to your website and you can look at this, right? And then start prepping yourself if you want to get involved. So any students out there want to get involved, this is what you got to do. I'll give you the links in the video so you guys can go and check it out.
And there's more. I mean, actually, that was before even the start the project with Google and Skywater. And this is maybe the next thing if you would like, we can talk about it.
Okay, so let's talk about your projects. Some of the work that you're doing above and beyond, obviously, this initiative. Before that, I just want to stay on that point with the intention. Remember the original idea was democratizing silicon. Mm-hmm. That's a noble cause in itself because it hooks into all the open source. Well, it's kind of a natural iteration of the open source movement, and it's like open source hardware with RISC-V and all that sort of stuff. How do you think this is going to play out? Because I think it's a very early beginnings. I'm very bullish and very excited about this.
So I'm a believer, and with a lot of guidance, a lot of learning from the partners. Like one of our partners is his name is Jack Hughes, who founded several community-based companies, and one of them is called Top Coder, and the second one is called Tongal for video development, instead of studios. And it's amazing to see the innovation level and in the community, and who comes up with the good stuff. Basically, we approach the problem from that perspective, is that we need to enable a lot of designers so they can address a lot of applications in the long tail. So that is, typically, if you want to do this in a company, you have to choose what to focus on to put your team on. So you have to say, I'm going to work in the team, the things that would give me most profit, even if it's profitable, most return on investment.
Yes.
Now, as we go, we believe that's the bet, and I believe it's coming, is you can see it supported by many market leaders, is that the long tail will need customized applications or solutions, but who's going to build that? There's no one company that can build thousands and thousands at the same time. So we say, okay, let the world develop it, and we build a platform and let people develop even for their local needs as well.
So it's like a niching, it's a niching idea, right? Where you mentioned already, niche markets, right? Where the volumes are not there, but if the tools are there and the cost is low enough, then things that will never be done can be done.
Can be done because it's actually not about the highest revenue. It's about, is it an economically sound or not? So so any one of these niche applications, if you look at the cost of development and the revenue coming out of it, and you just if you reduce the cost of development significantly, then you have a higher chance of selling it.
A bonus point to that is that ideas that were left on the shelf can actually come into being.
So this is actually, a very important one, because of the industry dynamics, the technology. I call it, people look at the sun, they don't see the stars. Okay, so when the technology started to work from I worked in the year 2000 on 180 nanometer. That was year 2000.
Okay, yeah.
I left TI at 20 nanometer year 2011, and then it's more now. You can see 7 and
5
3.
nanometers now, right?
5 and 3.
Yeah.
So it gets more expensive. So the development cost is expensive. The number of capable or entities that can afford that is going down, and hence designers go to zero. They go to the designers inside these companies. So it makes it very hard for smaller companies to emerge. And there are actually, I have to say that the industry stakeholders, EDA and IP and foundries, they have programs to support startups, but it is limited by their ability to support it. So they have to choose. Somebody has to make a judgment. Is this worth my time, my tool investment, my money? Yes. And because of that judgment, you may actually put down a good idea. So we believe is that don't judge the idea, let them develop it. And if the market says it's needed, then, and I use the example of Angry Birds. I imagine the person who developed, or the company that developed Angry Birds, if they had an investor and they're trying to pitch Angry Birds before it gets developed. Okay.
Well, they pivoted. I think they had one idea and they pivoted towards another one, and then that became successful. But they could do it, because.
But who decided? It's not an investor.
No,
it's the market.
It's the market. It's the market. So this is a numbers game, right? Idea, right? So you put enough designs out in the market, and then some of them will stick. But if you never attempt those designs in the first place, then you never know which ones are going to.
And I have a statement. I say people think that I say you cannot manufacture or engineer disruption. You cannot say I have a disruptive product, disruptive idea. You can, of course, but the reality is we don't know. Okay, so as you said, let them go, and the disruptive ones are going to pop up automatically.
But I also believe that it gives access to this technology to parts of the world that don't have access at the moment as well.
So people say it's actually, if there's a numbers. In one of my presentations before. So what does efabless do? We enable more people to make more chips for better life. If you think of that statement that I just made, the number of people that are making chips today is very small. It doesn't say it's not big enough, but it is small compared to the population of the world, or even engineers,
very small,
or even electronics engineers in the field that have no access.
But there's a lot of talent as well out there that is not getting access because they're in the wrong country, right?
Exactly, and that was a part of having the browser accessible approach, is that it doesn't matter where you are, you can be in.
So you can allow the world to tap in. There's lots of areas of excellence around the world that don't have access, because this stuff is very expensive, and only the first world countries, most of them have access to this technology. So giving that access is going to, and also it's going to spark that interest in engineers of the future. I think that's another aspect.
So this is the bigger picture. But I'll tell you, we were there here in the United States. There is a problem that there are 3,000 universities, or call it, thousands of universities that exist, but we can count 20, 50 that actually have resources and access to a lot of things. There is a lot more that is even in the United States.
Yes, there's a great idea. You and I can geek out on it. It's awesome. We're engineers, blah, blah, blah. But some people may not get it, So you got to break it down into stuff that means something to them. So let's say I'm an engineer, or I'm a student at university, because this is where it's going to be aimed at. And I've done my first degree, or I'm on my first degree, or I'm on doing a master's, or even a PhD. And I'm like, it's all right. I'm enjoying it, and I'm doing some stuff and everything. But what's going to pique my interest to get involved in this program? What do you think what can we talk about, and maybe some examples or some thoughts that you have to get people excited about leveraging this technology for. I mean, Naveed mentioned jobs and, getting access to a network, and that's great as well. That's a really good selling point. But is there anything else that you can share that I can pitch to students so that they get excited about getting involved?
To be realistic, there's no, if you expose the entire world, 7.5, 8 billion people to something, not the entire world is going to get excited.
No.
So, however, so two things happen if you expose more people, and also you enable these students early in their life to practice something to know whether they like it or not.
Sure.
Okay. Some people like to go to be an engineer because it's prestigious in their country. Okay. I was breaking stuff for my dad when I was 7 because I wanted to see what's inside. So it depends. So I think there's no one formula, except that when you enable people to see what's available, and that's happening in some of the schools now, or a percentage of the schools, where they, like examples as robotics and the maker movement, etc. So in this case, I will say it. There's nothing in the world that doesn't have semiconductors. Anything useful around you, to look around you, okay? And this is just the start. So eventually,
everything's going
to have some piece of semiconductor.
Ubiquitous computing, everything's going to be having something.
Yep. So the other thing is the practical aspect. So I think nothing beats you holding something in your hand and actually feel what it does. Like here's one of our chips here. This is the memory, but the chip is in the back.
Okay.
We're reading the data in and out on the chip.
Yeah. Right.
From the memory side. Now the test here was a blink test. Okay, that was the ABC.
Yeah.
And then obviously you can control other things and other devices and movement, etc.
Okay.
So
you got some pins there that you can activate. Yeah.
Yes, you can activate and control with software. So this is simple enough that you can actually write a program in C and an IDE.
Yeah.
So trying that now, again, it doesn't guarantee that someone is going to like it, right?
Sure.
But at least it is available for exposure, so that to see whether they're going to resonate with it or not.
So the message here is give it a go. And secondly, you're going to get access to tools you would never, ever else get access to until you actually join a company. You're lucky enough to be working with a company that's got a big enough budget to be having those tools. Whereas now you've got the opportunity to be part of a process to get hands-on experience, which is going to really set you up for your career. If that's your thing, that is, obviously, right? If it's not your thing, then of course it's not your thing.
Yes.
But it's for the first time, it's giving you access to tools that most people will not have access to. So you're really going to be in the top, 1.1%, whatever, of the people around the world that are going to have access. So at the end of the day, it comes down to your personal desires. And that's what I always say to engineers. Look, if you're not into it, you're not into it. It's not your thing. Don't even do it, right? Go and do something else, right?
We started with, for the digital designers, a very streamlined platform for generating digital hard macros or IPs. Mm-hmm. And basically you work from Verilog all the way to GDS. But we made it so easy to trading off the area and the performance a little bit, but with the intent of making it finish and complete. So enables a lot more people to actually work and develop something without having the need to actually go to the layout. We also, as a part of the program, we provided a harness. It's basically a chip that is not complete, kinda, and then give you an area inside it to hook up things inside it to look like this. So we give you a box, you can do whatever you want in it, and then that drops, and then you assume that this chip is a small microcontroller. It has an area of a management area that is a small microcontroller that allows you to read and write and a logic analyzer, etc. And the resources available. This chip is available open source on GitHub in a very structured way with the documentation and data sheet. When you get into the program, you get actual boards like what I showed you earlier. You get this board, you not just get the part. So that's another way of simplification, is that what you get is something that you can actually boot and start right away and put it on the bench. we also, the community engagement around the project with Skywater, which is the foundry that we started with in the open source project. It is fascinating to see how fast this community grew, and how many channels and how many topics are being discussed. And because of the nature of the designs and the openness, people ask each other and faster than anybody else. What we worked a couple of programs with, or a program with Google that has multiple shuttles or tape outs.
Yeah.
We had the first one. We were asking how fast people will do it.
Yeah.
It was 30 days, 45 designs showed up.
Wow.
And half of the people here did not design a chip before.
Wow.
Half of the people here, they were coming from, they are passionate about engineering. Some of them took off time from their work to actually do something. This is how committed they were, and they were not chip engineers. One of the reasons it can actually work is that they're not working on the whole chip, developing the entire chip. They're developing pieces of the chip, and a lot of the complex aspects of that are already hardened and ready.
Okay.
So, yeah. So what we created.
So talk a little bit about that. So they get this area, which is they can build whatever they want in that area. To access that area, the custom area, there's a built-in microcontroller that gives access to investigating or talking to their custom area. Yeah, is that how?
Yes. So it has a bi-directional bus interface, wishbone bus. Okay. But also it controls the I/O programmability, and you can configure the I/Os around the. And then we've seen people use it in many ways. If I zoom in a little bit here, so you'll see the different designers have used it different ways. And analog designers, they have plenty of area. Digital designers, some of them did not have enough. Okay, depending on the size and what they're doing. We had freshmen in college here build a 32-bit CPU on this project. Okay.
So one of the questions that people might have, they might say, well, okay, that's great, but why can't we just use an FPGA?
This is not just the question of it's not just an FPGA, it's custom or not, custom ASIC or not. So an FPGA is still an expensive proposition if you wanted to. It has its part, and I do think that's unbeatable from a form factor perspective and power perspective to squeeze in a little chip in a sensor and throw it in the forest to catch something, or to sense something. That's not going to be happening with an FPGA.
Right.
So you need to have a right size compute, basically, as one of my friends say, and that means you can really shrink the needed power and resources to the level where the application is needs.
That's a very good point.
Working from a standard part where you have to an FPGA, or a standard part where you get a plate of things that you don't know. You leave resources unutilized, and it becomes an over design.
That's a very good point that you made earlier about a custom design that you can use for things like a sensor node or something, right? Where it's very low power. It could even be energy harvesting, and you could just leave it out there because it's because it's an ASIC, or it's not a FPGA. There's also degradation issues with the FPGA. Correct. As far as its long-term life versus an ASIC. So there's lots of unique use cases for doing this over an FPGA.
So the program basically, we called the program that we offered the package. It's called Chip Ignite. Mm-hmm. And from the name, that's the intent, where you get the initial design. You'll be able to design on our platform or off platform, depending on, and then you'll be able to submit it for tape out automatically on our website, gets checked and certified, and in a very smooth process.
So what about the actual silicon? How long does it take when it's when it's taped out, and when does the silicon come back? Does that vary?
if no problems, things are worked out. So this is an example here.
Okay.
So this is call it June, July,
Yeah.
August, July, August, September, and a little bit of October. So 3-something month.
Okay. Okay. Cool. Cool. Okay.
And then
Awesome.
we're working on improving that, because there are opportunities to actually make some choice and packaging or process technology that will shrink the time a little bit. But we found it's very convenient and supportive of the like, for example, in universities, you can actually go design in the spring, go to the summer, come back in the fall, and do the testing. So
Cool.
These are things that are possible.
Okay. Awesome. That's good. So that's fairly clear on that. Okay, that's great.
Our first users just in that area,
Yeah.
Stanford University, they had a VLSI design course. They used that concept of spring,
Okay.
summer. They did that with us.
Okay.
And their IEEE Solid State Circuit Society, they created a competition.
Yeah.
And they are using the platform. And then
Okay.
thirdly, the
Tape Out Initiative. Yeah.
the Tape Out World Program by the FPGA Foundation.
And you've done a number of those already, right? You've done a number of those.
Yeah, we haven't done the tape outs yet, but we have done several engagement in terms of content, as well as training, as well as just Q&A.
Okay.
In the country, at least in these, in the countries here. Australia is obviously coming.
Yes, so, yes. No, don't worry. We're going to get some traction here. I think, Australia is very open. I mean, Australia is very, very open. They're very open to new ideas. A lot of innovation going on in Australia. It's a small country, small population, but the ideas that Australia puts out to the world is pretty awesome. To be honest. And they embrace change. Australians love tech. It's the first country that companies put a product into to test it to see if it will work. If it works in Australia, it's going to work. It's going to sell in other parts of the world. So Australians love tech. They just love to absorb it, and they get very involved. Awesome. It's a great program, Mohammed. I love it. You're doing a fantastic job. I think your company is doing a great service as well to being an engineer myself. I think
it takes a village. It takes a village to do that. So a lot of people doing a lot of things, and we're just presenting it in a way that people can use.
Yeah, and I think that's just going to get bigger. I think it's just going to get bigger as more people get involved. They can build up that community, and people will start to see how this is going to benefit and roll out to other people. So, look, I'm really, really happy that to be part of this initiative, Mohammed. Thank you very much.
Well, thank you for the discussion, and I'm looking forward to working with the team in Australia. For technical training and tipping out their chips.
Yeah, well, I'm working with Diane, and obviously, so anybody listening to this video, watching this video, looking for champions in Australia, anybody that's going to champion this initiative, I'm going to be involved in it, obviously, but anybody that can drive this more for regular basis, I'd love to hear from you guys. So, Mohammed, thanks very much for all of that insight. It's been really, really educational for me as well.
Thank you for giving me the opportunity to talk.
Awesome.